Hello everyone. My name is Mithun Das. I am doing my PhD at IIT Kharagpur under the supervision of Professor Animesh Mukherjee. Today I will be presenting my work like classification of different participating entities in the rise of hateful content in social media. Before I proceed forward with the presentation, so I would like to thank ACM Sigar for the student travel grant to support my journey throughout the conference. So the presentation content material that many will find offensive or hateful. However, this cannot be avoided owing to the nature of the work. So hate speech or abusive speech is a problem across various platforms, whether it is a platform like Twitter or a Gap. So Twitter is moderated platform. There they have some restriction, and Gap is unmoderated platform. So therefore it needs to be mitigated in any way. Also, it has been seen like the public expression of hate speech promotes the devolution of minority member. Also, like further frequent and repetitive exposure to hate speech could increase an individual's outgroup prejudice. So therefore, what can be the solution? So the solution can be detecting hateful or abusive post. So basically, individual level post can be detected automatically that are being posted on social media platform. So which leads to the following research question, like how can we enhance the detection of low resource multilingual abusive speech on social media? So basically in the NLP domain, most of the work that has been done so far like focused only on the English language, but also for detecting hate speech, the work on hate speech and abusive speech is also no exception. But although as the social media platforms are multilingual, so we need to have models or mechanism to detect low resource hate speech also. Recently, many smearing incidents have been observed in India, like which provoke diverse form of abusive speech in the online space. So therefore, it is essential to deal with such malicious content in Indic languages as well. So basically in this work, we try to bridge that gap, like we demonstrate a large scale analysis of multilingual abusive speech detection in Indic languages. So now I will proceed with the data collection part. So basically for data collection, I have curated the existing data sets that were already available in the research community. So in total, like I have accumulated 8 data sets and 10 types basically from the 14 publicly available sources. So this Hindi, for this Hindi, if you see, like I have divided the type as Hindi and then Hindi English. So this is basically code mixed kind of Hindi. Here English and Hindi both are combined while writing posts on social media. The problem was like all these data sets does not have binary label. Some has multi-label. For example, some are labeled as hate speech, offensive speech, or normal speech. However, to pose the problem as binary classification, apart from the normal speech, like I have combine the other labels such as hate speech and offensive speech. In terms of modeling architecture, I have used the following two transformer-based model, MBAT and Muril. Further, like several interlingual transfer mechanism I have tried, like for example, this each ELFI, like here we use the data from the same language only for training, testing, and validation. Then this joint training, here we combine all the data sets in all languages to train the transformer-based model. Further, we perform model transfer. Here the models have been trained in one language, let's say source language, and directly we assessed its performance on another language's data sets. Then the instance transfer. So this is almost similar to the model transfer, but instead of directly assessing target languages in the source languages model, we first use the Google Translate API to translate the target language instances to the source languages model language. Basically, let's say I have a model that is trained on Bengali, but I want to check its performance on Hindi language. So I translated Hindi language first to Bengali language. Then on the translated data point, I checked how the model is performing. Then coming to the synthetic transfer. So in that case, like if there is no data sets present at all for a given language, how can we use the existing existing high resource languages such as English and translate them into these low resource languages and have our base model, like the English languages data sets can be translated to Bengali and Hindi. Then we can create our model with this translated Bengali and Hindi data point. Now we'll talk about the results. So these are the performance of both ELFI style training and joint training. So if we observe for the ELFI style training, out of 10 languages type, like Muriel outperform MBART in 7 languages, like in terms of macros F1. Also, if we see the performance of joint training, we can see for some model the performance have improved from the ELFI style training, but for some also it decreased. However, the improvement and the decrease of performance is not that much high. So therefore, we recommend to use the ELFI style training, because joint training is more will take more CPU or GPU, like as the dataset will increase for combining all the datasets. So this is the results of the model transfer. Yeah, the present slides is a bit of clumsy, I can understand, because we have a lot of languages. So in this side, these are the target languages on which we are testing a model's performance, and these are the source model. So in summary, I will say what we have observed. So we observed the languages which belongs to the same community, the transferability across them are better. For example, this Bengali, Hindi, Marathi, all those belongs to the Indo-Aryan language family. So therefore transferability among them is good. On the other hand, this the Dravidian language community, Tamil, Kannada, Malayalam, the transferability among them is better. So this is the performance of this instance transfer. So what I have observed from this instance transfer and the model transfer performs better in the case of instance transfer, as we have to translate the target language's data point to the source language. This translator sometimes reduces the toxicity score present in a text, so therefore the performance dropped. So this is the performance of the synthetic transfer. Here, although we can see, with the synthetic data point, we are able to get some performance. However, like if further we add like gold target instances, so then the performance increased. So gold means the actual annotated data point, not the synthetic data point. So now I will talk about the robustness against several adversarial attack of this model. So basically we have experimented with the following 6 adversarial attacks. So these are remove spaces, then add spaces in words, then remove characters from words, then like you introduce special characters in between words, then we can swap adjacent characters also, then also we can swap adjacent words also. So these are the performance of the model for different languages. As we can see, for all the languages model, when the adversarial attack increased in the text, the performance of these models dropped. So what are the challenges of post level detection then? So the challenges is like if the context of a post is ambiguous, in that case it is difficult to decide like whether a post is hateful or not. Further, we have seen this adversarial attack can fool the hate speech detection system. So what can be alternative solution then? Solution can be like detecting hateful users. So the users who are specifically engaged in spreading this hateful content, which leads to the following RQ, like how can we detect the users spreading such hateful posts? And before moving forward, the advantages of detecting hateful users are like majority of these hateful posts are generated by only few hateful users. Also, these hateful users are densely connected. So this might be helpful for us to detecting these hateful users. Now coming to the data collection part, we have selected these 2 platforms, this Gab and Twitter. So Gab is a social media platform which promotes itself is a champion of free speech. On the other hand, Twitter is more like mainstream social media platform which has its own moderation policy. So for the Gab data collection part, like we use the existing crawl dataset shared by Matthew et al. And basically the dataset has been crawled by this Gab's API and standard snowball technique. The final dataset contains 381 key users and their followership network. So now we sampled the data point before we develop our models. But to ensure sufficient representation of both hateful and non-hateful users, first, we created a lexicon of 45 hybridization terms, including various derogatory terms, and identify hateful posts based on this, based on the presence of these hateful keywords. And initially, we selected a set of 2,769 hateful users, considering like these users at least made 10 such hateful posts. Then we created a repost network where the node actually represents the users and the edge weights denotes the reposting frequency. Finally, using Decrude's model, a belief score has been assigned to each users. Now, like we select our users for annotation. So basically, we cluster the users into 3 categories, like high, mean, and low. Then from this each 3 category, like we randomly sample 300 users. And with the constant that at least each user must have been posted at least 10 times. So for the Twitter datasets, we have used the existing crawled annotated datasets shared by Riorio et al. The datasets has been crawled using Twitter API, and the data sampling strategy that they have used is similar to the one that we used for our GAB datasets. However, like unlike GAB, like instead of the followership network, they have used the retweet network. Now coming to the annotation part, like this is the annotation guideline we provided to the annotator before labeling a user as hateful. So basically, a user is defined as hateful if the user endorses content that is humiliating, attacking, or insulting to some groups or individuals based on several protected attributes. Now, using these guidelines, 2 annotators basically annotated the 900 users, and further the conflicting cases, like we removed those from our datasets, which leads to a final count of 423 hateful users and 375 non-hateful users. So, then we created the followership network of this user. Basically, we have constructed the 1.5 degree network of this labeled users and their followers and following, and the connections among themselves. So the nodes basically in the network represents the user account, and the edge represents the followership network among the users. Further, we pruned the graph by removing the users who has made at least like less than 10 posts. So the filter graph has finally 47 key users with 13.8 million edges. So this is the final dataset for both GAB and Twitter. Now regarding this detection mechanism, so we have experimented with several models ranging from text-based model, network-based model, then this graph neural network-based model. And in summary, like what we have observed, like this graph neural network-based model such as AGNN, like which combines this both textual and network features, exhibit improved performance compared to this individual text-based and network-based model. The thing is, the discussion that I had so far only considered the textual content that are being posted by users or the text that have been posted on social media. But however, the content that are present on social media is multimodal. So for example, memes, videos, all those stuffs can be can be posted on social media platforms. So therefore, our next work try to focus on detecting this multimodal hateful or abusive content. So this is our ongoing work. So the motivation is, as like in recent times, these internet memes become popular on social media platform, and it has been already observed these malicious actors use this meme to jeopardize or abuse individuals. So therefore, we need to detect this internet abusive memes. Further, this video hosting platform also is growing rapidly day by day. But on the other hand, people are using this video hosting platform to propagate like misinformation, hate speech. So therefore, we want to identify those hateful videos also. So far, like few work has been done on this abusive meme detection, only considering the English language, but in the multilingual space, no work have been not much work have been done. So we focus on detecting multimodal, multilingual, multimodal hate meme, then these hateful videos. So our plan of action is basically first we want to curate datasets. So for the meme dataset curation, so for the time being we are just considering the Bengali and Hindi language. So we created lexicons of hateful term for Bengali and Hindi. Then we performed keyword-based web search on various platforms and tried to scrape images that we got as a search results based on those keywords. Yeah, and for the videos basically we have used the existing derogatory lexicons that have been shared by Matthew et al. And using those keywords, basically we are searching videos on the BitChute platform. So BitChute is kind of alternative platform to YouTube. There people can post anything. And the link that are being returned based on those keywords, we are downloading those videos basically. So these things will be used for the annotation and develop data sets. In terms of model, basically we plan to use several text-based, video-based and audio-based model. As this is multimodal content, yeah, we have to come up with some new multimodal model combining all these kinds of modality. So some fusion-based techniques maybe. Yeah, so this is my overall work. So in conclusion, so we first demonstrated a large-scale analysis of multilingual abusive speech in Indian languages. We experimented with several interlingual transfer mechanisms. Then we detected hateful users, like we experimented with several supervised, semi-supervised model, and we have found these semi-supervised based GNN models which use both textual and network features perform better. Currently, we are in the process of developing multilingual abusive memes and video datasets to improve the detection models. Thank you.